Hello, my lovelies. It's Susanna, and today I want to show you how to solve this puzzle. The figure consists of 6 individual squares. What is the area of the red square if the area of the green square is 4? The squares fit together flush as shown in the figure. Okay, so we have these 6 individual squares here that are all connected to each other. The area of this small green square is 4, and we have to find the area of this red square. So let's make this figure a little bit bigger because this small square is so small. And maybe let's start with this square because actually this is the only information we get here. We get the area of this square. So what does this tell us about the length of the sides then? Maybe you see that it has to be 2 and 2 because 2 times 2 equals 4, but maybe the numbers are sometimes a little bit more complicated. So if we don't see it that easy, you can always say, okay, I don't know the length of this side, but if this is A, the other side has to be A as well because it's a square. And then I know that A times A has to be equal to 4. So A times A equals A squared, and this has to be equal to 4. And then you only have to solve this equation for A. We want to get rid of the square, so we take the square root on both sides of the equation. This helps us to get rid of the square here, and we will get 2 solutions for our A. A first positive solution, A1, and a second negative solution, A2. The positive solution, the square root of 4, just equals 2. And then we also have negative, the square root of 4, so negative 2. But here we don't need the negative solution because we're searching for the length of a side and it's better positive. So only 2 is the only solution for our problem here. So 2 and 2 is what we have here. Okay, if that is the case for the small square, maybe we can take a look at the next larger square here. We know that this part is of length 2, but we don't know the length of this part, so I just call it x. So in total, I have a length of x plus 2 for the side of my square here. So if this is x plus 2, then I also have x plus 2 here because it is a square, right? Okay, but if I have these two here, I can also say what the length of this side here is because it is 2 plus x plus 2, so x plus 4 in total. Okay, if this is x plus 4 and this is a square, then I know that this is of length x plus 4 as well. Okay, then let's go to the next bigger square here because we also know the length of this small part here because this is the 2. So in total, we also know the length of this side here. It's x plus 4 plus the 2, so in total x plus 6. Because it is a square, this is also the length of this part here. So this is also x plus 6. And this small part here is of length 2, still from our green square here. So we know the length of this entire side for this biggest square we have here, and it is x plus 6 plus 2, so in total x plus 8. Okay, we did all of this. For what? Well, actually we wanted to find the length of the sides for this square here. We found that this whole part is of length x plus 8, but this would be this whole thing here, and we don't want to have this part in there. Then we just subtract it. From the entire side, from the x plus 8, we just subtract this part here that was given with the length of x. So we subtract x to get the length of our square that we're interested in. X plus 8 minus x. X cancels out here, so we only have 8 left. Without knowing x at all, we just found out that the length of our square that we are interested in is length 8 of this side. Okay, so because it's a square, we can find the area now because it's just 8 times 8, so 64, and we are done. I'm curious how you solve this problem, so please let me know in the comments. I wish you a wonderful day, and I hope to see you in one of my next videos. Take care!